All right, hello everybody. This is how to make a first-person, third-person character controller in S&box. This is going to show you the basics on how to get a simple player controller up and running that you can set to either first-person or third-person at will, at runtime, on the fly, and even set it up with some animations. The controller will be capable of walking, running, crouching, and jumping. So, without further ado, I guess let's get started. First, what you're going to want to do is create the player object. I'm going to reposition it to 000 and name it player. You can go ahead and right-click on this and convert it to a prefab if you'd like and work on it in a prefab. But I'm just going to be doing everything in the scene for the sake of the tutorial. I'm going to add another game object underneath the player and call it the body. And I'm going to create another game object underneath the player and I'm going to call it the head. The body is going to be the visual representation of our character. So in my case, I'm going to want to use the citizen. You can use whichever model you'd like. You can even use a capsule if you'd like. But I'm going to be using the citizen because they are capable of a lot of pre-built animations that are provided by FacePunch and amongst other things. He just looks amazing. I love him. So I'm going to add a model renderer, specifically a skinned model renderer for our skinned character here. And in model, I'm just going to add the citizen B model, and there he is. Beautiful. Looking great. Fantastic. And because I'm using the citizen, I'm also going to add the citizen animation helper. This is not necessary if you're not using the citizen, but if you are using the citizen, feel free to follow along. It just has some helper functions so that we can animate him easily without having to know the names of the different booleans and float values, parameters for our animator. So now I'm just going to drag the model renderer into our animation helper, and I think that should be good to go. Now I'm going to take this head object that I created, and I'm going to roughly drag it to the head position of our player. This is kind of going to be where our camera emanates from. So if you think about it, the camera is going to be at this position right here when we're looking around. So this is going to be our first person view. And for our third person view, it's going to be however far back from this position it'll orbit around. So that's what this head position is. Now on our root object here, the root player object, I'm going to go ahead and add the player tag. You can name this whatever you want, but I just like to call it player. And then I'm going to add a character controller. And this character controller is going to ignore the player tag. This means that if we add more colliders to our player at a later time, be it for other things colliding with us or us pushing around physics objects or what have you, we won't get stuck in ourselves because it's going to ignore our own colliders. You can feel free to mess with these settings, but I actually think they're perfect for the citizen, the default settings. If anything, I actually might bring the radius down to about here, just because I think that looks a bit more proper. And I'm going to Control S to save. Now, before I get into any code, I'm going to make one last object, and it's going to be a camera object on the player. And we can position this just wherever we want for right now. I'm just going to put it somewhere where we can see everything. I'm going to increase the field of view as well. There we go. So now that should be good. This camera is going to be positioned via code later, so it doesn't really matter where you position it. I'm just putting it here so that I can see what's going on once we have something up and running. So now we can go back to the player root object and add a new script. I'm going to call it the PlayerMovement script, but you can call it whatever you'd like. I'm just going to use the simple component template, and I think that's perfectly fine. So in this script, we're going to add a few movement properties at the very top, which are going to allow us to change how the player controls from the inspector in real time. So to add a property, I'm just going to first say movement properties. You just simply add the property attribute to your variable, and then you just make sure you follow it with an empty getter or setter, as long as it has a getter or setter. And I'm just going to create all of these default values real quick. All right, so these values here are pretty good defaults. You can feel free to change these up if you want, but because they're properties, we can just change them in the inspector at any time. So you can see that if I click back off of our thing and back on, oh, it didn't add our player movement, so I'll just make sure I add the script back. You can see, boom, we have all of these as nice little sliders. So this is our base speed, our movement speed. This is our speed while we're holding the run button, and this is our speed while we're holding the crouch button. And we can just modify them however we'd like just by dragging them. So now let's add 2 more properties so that we can get some object references. These are going to be our game object head and our game object body. Now, you don't have to make these public. I honestly probably wouldn't. There's probably a better way that you can go about getting these if you need them externally. But I just like to make them public just in case I need to get the body position or the head rotation separate. Now I'm just going to have a few member variables. First, I'm going to add the wish velocity, which I will default to 0. And this velocity is the velocity that our player wishes to be moving in the current frame, which we'll write a little function to calculate in a sec. And then I'm going to add booleans for is crouching and is sprinting. And then I'm going to grab a private reference to the character controller. I'm actually going to call it character controller with the lowercase, just because that's my preference. You can call it whatever you'd like. And then because we're using the citizen and we're using the citizen animation helper, we're going to want a reference to that. So get our citizen animation helper, which does require us to import or use sandbox.citizen up here. And I'll just call it animation helper. You could do both of these through properties the same way these object references are. So we'll just be able to drag them in, the player movement or character controller or whatever. But in my case, I always know that these things are going to be attached, so I'm just going to cache them in my onAwake function. So let's do that real quick. onAwake function, and look, Copilot's kind of trying to carry us, but it's not really doing a good job. So we want character controller equals components.get, our character controller component. So calling this components.get is going to get the character controller that's on the same object as us. But now for our citizen animation helper, it's not. So I'm actually going to go ahead and just move it because it's just a little easier, and it doesn't really matter where it is because it's targeting this skinned model renderer. As long as this animation helper is targeting the skinned model renderer, then we're good to go. Otherwise, you can just add in here get in children, I think it is. Whoops. Get in children or self. Yeah, there you go. So you can do it either way here. So now let's get our animation helper. Beautiful. Now back in the inspector, I'm going to go ahead and add references for the head and body. Just going to drag the head object into the head property and drag the body game object into the body property. Going to Control S to make sure our scene is saved and all these references are hooked up, and go back to the script. Now let's build that function for calculating our wish velocity like I was mentioning earlier. At the start, you just want to make sure that it is 0 before we do any of our calculations, because assuming there's no inputs being pressed right now, we want it to have no movement, our player. And we want our movements to be based on the rotation of our character, the forward direction that we're looking. So let's get that rotation right now. It's simply just your head transform rotation, but I'm just going to put this in this little rot variable to make my life a bit easier. And there's probably a little more elegant way you could do this here, but I'm just going to simply check each input and add it to our wish velocity. There we go. So now all this is going to do is, if we're pressing forward, it's going to add, I guess, a unit vector of 1 in the direction of our rotation. So this is a normalized vector currently. The length of this vector is going from 0 to 1. And we're going to want to make sure that you can't move up or down. Like if you're looking up into the air, you don't start just moving upward. We want to keep the player grounded. We just want to set the wish velocity equal to the wish velocity with a z of 0. So now, because this is a unit vector, we're just going to say if the wish velocity isn't near 0, then set it to the normal. Don't set it to the normal times speed. And then finally, we can multiply it by the speeds that we've set earlier. And now you can see it's actually trying to do it right now for Copilot. Thank you. GitHub Copilot coming in clutch. This is exactly what we wanted. If we're crouching, we'll multiply by our crouch speed. If we're sprinting, we'll multiply by our run speed. And otherwise, we're just going to go at our normal moving speed. And this order does matter because crouching should take precedence over sprinting. So for example, if you're holding the crouch and sprint button, if you had this first, you would be moving at the sprinting speed while you're crouching, and that's not something you want. So this order does matter, and you just got to be cognizant of that. So now let's build a function that is actually going to apply the movements of our wish velocity and take gravity into account. This is a really easy function, and I'm just going to call it move. And the first thing we want, obviously, is the gravity. And we're going to get the gravity from our scene, because the scene has its own global physics settings, and these physics settings are shared and can be changed at any moment. So if you want to be able to control the entire scene, it's good to do it like this. Otherwise, you could create a vector3 property for your player that has a custom gravity that is independent from the scene's gravity. But I like to do it this way just because it's more in line with the rest of Sandbox. So we just want to do scene.worldPhysics or physicsworld.gravity. And that should just give us a vector3. If I hover over here, yep, it's a vector3. And that is in the downward direction. So now we'll just do a quick check here to see if our character controller is on ground. And if he is, we're going to apply our friction and acceleration. And the way we do this is you can say character controller dot velocity equals exactly this, our character controller velocity with a z of 0, because we're on the ground. So if we did have a previous velocity, if we were just falling to the ground and we now hit the ground, we're resetting that z velocity so that we're no longer falling into the ground. And then we want to go character controller dot accelerate our wish velocity. I made a few mistakes while I was writing this function in the original video, so I'm just editing this in post. After the accelerate function, you just want to apply friction, which is going to be our ground control variable from earlier. Now, this is because we're currently on the ground. Now, otherwise, if we're not on the ground, what we're going to do here is apply the air control / gravity. And what we do here is our velocity is going to add that gravity vector that we got right here. And we're going to multiply it by time.delta, which is going to be the proper delta no matter if we are in the fixed update or the normal update. This is going to calculate based on the scope that we're in. So we don't have to worry about this being a fixed delta or whatnot. Now what we're going to do is actually multiply by 0.5, because what we're going to do is apply half of gravity before the movement and the other half of gravity after movement, just to make sure all of our calculations are done with 100% accuracy. And then here what we do is not this, but we are going to accelerate by the wish velocity, but in the air, we only want to move as fast as our max force that we set. Which is going to be as easy as dot clamp length and our max force. And that max force from the very top here is just 50 by default, and you can make that whatever you'd like. Then we're going to apply the air control friction, which is by default a much lower value, so it's a lot harder to move in the air. But like I say, you can customize these values to your likes. Then we're going to simply move the character controller, which is character controller dot move, which takes no parameters. It simply is going off of the velocity and acceleration and friction that we've set with these functions. And then we can apply the second half of gravity after movement, which we can say by checking if we're not on the ground. And if we aren't on the ground, we'll just say the velocity is added with the half gravity like we did earlier. You could also save this in its own variable if you'd like. And then character controller dot velocity equals the velocity with the z of 0 if we're on the ground, just like right here. So if we hit the ground, we want to stop our speed, just like earlier. So now let's take a look at what we've built so far by just throwing it all in our update functions. In the onUpdate function that it gave us by default, we're just going to set our sprinting and crouching states, which is crouching equals input.down crouch, and is sprinting equals input.down run. And these inputs, by the way, the names of these inputs, I've been going entirely off of the default names, except for crouch here. Crouch is not actually what it's called. It's called duck by default, but now is a good time to show that you can just come over to your projects tab here, right-click, and edit your project, and go to your input tab, and add as many inputs as you'd like here, or rename them. So I'm going to rename duck to crouch, whoops, because that's what I prefer. And I'm just going to save it, and we should be good to go. Now, back in the script, I'm also going to go ahead and add a protected override void on fixed update. I said on fixed update. And what this function does is, instead of being called every single frame like on update, it's called every physics update, which you can modify by going to your scene and clicking on the root of your scene and seeing this fixed update frequency. So you can change it from 50s, that's the default, change it from 50 to 60, 120, change it to 1 even. Make this whatever you'd like. So in our onFixed update, because our movement is very physics-based, we're going to do all of our movement in the physics update. So all we need to put here is build wish velocity, so we can determine what our wish velocity is, and then move. Pretty simple. So let's take a look at our player and see how that worked. I'm just going to move this as an animation helper up. I'm going to collapse it here because I don't need to look at it anymore. Actually, I forgot to drag the head into our citizen animation helper, so make sure we do that. So now you can see when we run play mode, our character is able to move around. It's moving through things, but it is able to move around. The only reason it's moving through these things is because I don't have colliders on them all, but I'll add them right now. I'll show you how I can do that. So this guy has a box collider on it with no tags, so I'm colliding with this ground. But these guys just need their respective box colliders. Box collider. Box collider. And now I can no longer collide with them. So that's how you set collisions for it. It's just anything that's not tagged with player at the moment. But I would also recommend adding the trigger tag here as well, so that you can, for example, say create a box collider that is a trigger, but see, I should be able to walk through the trigger. But if I give it the trigger tag, now I can. So now this is a proper trigger zone. So that's just what I would recommend doing. Again, totally optional, but just nice to have. So this is nice and all. We can move. If I hold sprint, I can move faster. If I hold crouch, I move really slowly. But I'm unable to move the camera around. I'm moving my mouse all over the place, but nothing's happening, so I can't really change the direction that I'm moving. So let's do something about that. I'm going to go over to our camera object that we created earlier. I'm going to add a new script and call it CameraMovement. I'm going to make sure it's a new simple component, and I'm just going to save it exactly in the same place. This is similarly going to have its own properties. These properties are mainly just going to be object references. So I'll just say these are my properties: player movement, player, game object, body, game object, head, and we have our property public float distance. And I'll set this to 0 by default, which means that it's going to be a first-person view. This is going to be the distance back that the camera travels from that position that I was talking earlier. So if it's set to 100, you're about 100 units pulled back from the character's head into the third person. But if you're 0, you're first person. So let's add a few variables. First, this one really isn't a variable. It's like a little arrow function, I guess. If is first person is just going to be if distance is 0. It's just going to be a lot easier to check that than it is to check distance equals 0. or at least it's a lot easier to remember. And then I'm just going to make a reference to our camera component. I'll just call it camera. And in our protected override void on awake, I'll just get the camera component. Since I know it's going to be on the exact same game object, there's no reason for me to do it through properties, but you could do it if you'd like. So now I'm just going to drag the player movement script on, I'm going to drag the body game object on, and I'm going to drag the head game object on. And I'm going to control S to make sure all this saves. Back in the script, we're simply just going to add to our onUpdate function, and that's pretty much all we're going to need to do here. So first we'll just rotate the head based on mouse movement. And the way we'll do that is we'll get a little eye angles variable here, which is our head transform rotation in angles. So instead of it being a quaternion or a rotation class, it is now an angles class, which means we have the pitch, yaw, and roll in angles. So we can say eye angles dot pitch plus equals input dot mouse delta, I think it is, yeah, mouse delta dot y. So this is our y movement, which I'm just going to multiply it by 0.1. You could find a better way to get your sensitivity, I'm sure, but this is just how I'm going to do it for the sake of the tutorial. The roll is always going to be 0 because it would hurt your eyes if you did a barrel roll. And we just want to clamp the pitch of the eye angle so that you can't look above or beyond the 90-degree mark. I'm just going to go 89.9. So it's like right at that 90-degree threshold. And then we're just going to set the transform to, it's actually eye angles dot to rotation. So now if we go into our scene view, and I'm just going to drag the scene off to the side of the game view and select the head, you can see as I rotate the mouse, that little gizmo is rotating with it. So that's the direction that we're looking now. So now what we need to do is just make it so the camera's position is moving with it and can raycast back from it for third person. So in the script, let's go right below this, say set the position of the camera. And we'll only do this if the camera is not null, just because I like to have some safety checks here. The cam pause is our head transform position. And we'll do a quick check here and say if we're not in the first person, we're going to perform a trace backwards to see where we can safely place the camera. And so the way we'll do this is we'll get the forward direction, which is our cam forward, which is based on our eye angles to rotation dot forward. And then we'll just build this trace here, scene dot trace dot ray from our cam position, and then from our cam position backwards, that's this minus, forward times the distance. Ignore whatever it just tried to give me here. And we'll say it's without the tags player and trigger. There, that means we won't hit the camera on a trigger, and we won't hit the camera on ourselves because we are the player. And we'll just run this. So what this is going to do essentially is, if our distance is set to, that's not the button I wanted to hit. If our distance is set to 100, then from this head position, which is looking forward, it is going to use this forward direction and send it 100 units back to position the camera right here so it can see behind us. And this distance can be as far as you want. So we can make it like 1,000. Be really zoomed out if we want. So if I look at it from this angle and it was going like 200 units out in this direction, it's going to stop right here because the camera hit a wall. And the camera's not going to let you see through the wall over here. I know my drawing is very crude right now, but hopefully that gets the point across. So now we just want to check if the cam trace hit, then our camera position is going to go to the trace hit position plus the trace normal, just so that it's a little bit off of the surface. That means if the camera were to just be positioned right here, you would kind of see some clipping because the camera's inside of these. So like, yeah, you can see through this whole block. So if the camera's just pushed out a little bit, now you can't see through that whole block. So that's why we do that. Otherwise, if this trace doesn't hit, we're just going to set the cam position to camtrace.end position, which is the position right here. And then after this, we can just say camera, or well, I'll say set the position of the camera to our calculated position, which is simply saying the transfer position is the cam pause, and the transform.rotation is our cam, or what is it, eye angles, yep, .to rotation. And that should be perfect. So let's go ahead, Control S, run it in game, and there we go. I'm able to move around just fine. My left and my right are inverted here, so I'm going to go back to the script and change this to be minus equals on the yaw, and that should, there we go, that works perfectly. But you'll see there's a little issue. When I look down here, I'm seeing my character's body still, which in the first person I shouldn't be able to do that. Now granted, if I come over to my player here and we increase our or sorry, not the player, our camera, if we increase this distance, you'll see we get that third person effect just like we want, and you can see the camera even hits up on the objects just like we want, and we can see the citizen just like we want. But our problem is we want to not see the citizen when in the first person, and only when we're in the first person. And that's really easy. So what we'll do is we'll go back to the script, and we'll get actually another reference here, but we'll just get a reference to a model renderer, and it'll be our body renderer. And the way we get this is our body.components.get. Get our model renderer from the body. And then all we want to do, there's a few ways you could do this. You could actually just set it to hide the player tag from your camera. You could set it to hide or just disable the model renderer component altogether. But the way that I recommend you do it is at the bottom of our is third person check, we're just going to say to show the body if we're not in the first person. We should do by saying body renderer dot render type equals what do we got here? I want it to be on. And then otherwise, if we're in the first person, we're going to hide the body. Instead of saying dot off, we say shadows only. And then what this is going to do is if we come back here, we can still see the shadow of our player, but we can't see the player himself. And if I go over to the camera component, I can increase the distance, and we can see our player again. But the second that we go back to our 0 distance, he's invisible. So that's perfect. That's exactly what we want. I'm going to set for the rest of this video, I'm just going to set it in the third person at about 150 distance, just so we can see what's going on from now on. Alright, so back in our player movement script, I'm going to go ahead and add a new function at the very bottom, below our move function. I'm going to call it rotate body. And what we're going to do here is first check if the body is null, then we're going to return, just a little safety check there. And this function is going to rotate the body towards our currently facing direction, based on the head. So first we're going to get the target angle, which is simply new angles 0 head.transform.rotation.angles. Actually, we can just do .yaw, I think. Yep. 0. So this is going to build out this angles, but I want it to be a rotation built from angles, so I'm just going to convert it to a rotation here. And the reason why I want this is because we want to get the difference between these two rotations. We can do that by saying body.transform.rotation.distance target angle. So now we have the difference in angles, or in degrees, sorry, between these two rotations. And so we say if the difference between them is greater than 50, or our character controller dot velocity length is greater than 10. So this just means if we're moving, we're going to face the way we're moving, or if we're looking too far over, we're now going to rotate in this direction. And all this is transform dot rotation equals rotation.lerp body.transform.rotation, target angle, and I'll just do it a small delta time here. Now we can just go back up here and add it anywhere in our on update. I'm going to put it above the move, body, rotate body. And actually, I'm going to go ahead and put it in the on update, just so that it's happening every frame instead of on the fixed update. So now you'll see I'm not going to look directly forward in the direction. It's going to kind of lag behind a bit, but if I start moving, then he'll guaranteed rotate in this direction. So you can change that angle difference if you'd like. This is just the way that many sandbox games have done it over the years, so that's kind of the flow that I have adopted, and I think it works really well. We're just about in the final stretch here, so let's add a jump function, and we'll say if the character controller is not on the ground, then we'll return as our little safety check, and all we do here is character controller dot punch vector3 dot up times jump force, and punch is basically just saying I'm going to push this character controller in this direction with this force, and that's really all it is. And if you're using the citizen animation helper, or if you're adding animations at all, we can actually just, while we're here, trigger the jump for our animation helper. And now we should be able to jump, which is what I would have said if I actually plugged it up. So let's go into our on update, and we'll do if input dot pressed jump. Beautiful. Now we're able to jump. Looks great. It doesn't actually look great because our animations aren't properly set up, but we do have a working jump, and it worked great. So I'm going to add a new function once again called update animations, and say if our animation helper is null, then we'll return, so we aren't accidentally running code on stuff that doesn't exist. And very simply, this animation helper class has with wish velocity function, which is going to just take in our wish velocity. It also has a with velocity, which is just going to take in our character controller velocity. It has aim angle, which we want to set to our head transform rotation, because that's the angle that we're aiming. We have is grounded, which we want to set to whether or not our character controller is grounded. We can say animation helper dot with look, and we can look at our transform head rotation forward, and you can see here there's weights for the eyes, the head, and the body. So what I like to do here is make it so the eyes are always looking directly at the thing, the head is weighed about 0.75 behind, and the body is about weighed 0.5 behind. That's just my personal preference, but you can make this whatever you like. Then we can set the move style to be citizen move styles run. You can set it to either, but I like the run. I think it just looks great. And then our duck level is going to be 1 if we're crouching, and it's going to be 0 if we're not crouching. Very, very simple. And now we're still going to be stiff as a board because we need to call that function at the very bottom of the on update. So update animations right after we rotate the body. And now look at that. Instantaneously, we got some beautiful looking movement, and he's able to look around. He's able to go back into this first person view and have all of his shadows look lovely and have me fall off the map. But there is one thing you'll notice right away is if you've been building a little map to test in, you actually cannot crouch under a small space. You can crouch and have a slower movement, but you won't fit in the tight gap. And you can actually drag the scene view off to the side and take a look at your character controller box, and you see it won't shrink with you. And the camera isn't moving down with you either, which is a lot more jarring when you go in the first person and you can very obviously see that you're crouching by your shadow, but your view isn't going down. So let's make this crouch a little bit better, and then we're finally able to send off this video. Back in our player movement, we're actually going to replace this is crouching with an update crouch function, which I'm now going to create at the very bottom. Update crouch, And all it's going to do is say if our character controller is null, return, because we're going to check it, so we just want that safety. So if input.pressed crouch, and we're not crouching, and we'll set crouching to true, and we'll set our character controller height to be half of its current height. And then we'll input.release, set it back to 2 times the half, which returns it to its whole original height. Very easy, very, very easy. And now you'll see instantly, I'm going to bring this scene view back off to the side. When I crouch, that is shrunk in half, and I'm able to crouch right underneath. Now, you'll have this problem here where if you uncrouch from a spot, you'll get stuck in it. I won't show you how to do it in this video, but what I recommend you do is when you release the input, you should do an upward trace to see if there is a ceiling above you. And if there is, then do not let the character to uncrouch. Just automatically uncrouch them once that trace is no longer met. That could be a fun little exercise for you guys to try after you finish this video, because I showed you how to do the trace for the camera earlier, so it's very similar in concept. So now let's make the camera move with the crouch. The camera movement script, scroll up to the top and add another variable, which I'm just going to make a vector private vector 3 current offset and set it to vector 3.0 to start. We're going to sandwich it in between our rotation and our camera, and we're going to say set the current camera offset, and we're going to have a target offset, which is by default 0, and we're just going to say if the player is crouching, the target offset is I think plus like 32, because our height is 64, so half of that would go down to 32. So this is our target. So when we're not crouching, we obviously don't want any offset to the camera, but when we are crouching, it's going to offset it down 32. And we're just going to lerp vector 3.lerp, boom, target offset. That looks fine. And then down wherever we set our camera position, right here, we just want to add current offset. And now you see the camera is moving up and down with the character smoothly. We're able to fit through our small gaps. And if I go into the first person, we'll do the same thing here. Excellent. Now you should be good to go, up and running with your player controller, first person, third person, the whole 9 yards. Hopefully this video is comprehensive enough to give you the full insight into what you need to do to set up a player controller with animations, with collisions, and all the different use cases and edge cases that you'll run into along the way. Sorry if it was long-winded. I wanted to make sure it was super comprehensive, but yeah. This character controller is a perfect starting point for really any game. On screen now I'm going to show some footage of a character controller that I made that is basically the exact same thing, just heavily modified. So I may make some videos in the future on how to do stuff like a ledge grab, a slide, stamina bars, but we'll see. It's all pretty self-explanatory, I feel, once you kind of get these basics down pat. Everything else kind of just fits together. That's what I love about S&box, and hopefully you guys got some good enjoyment out of this video. Thank you so much for watching, and go make some cool stuff. Later.